So today for Unit 4, Section 2, we're going to go over the properties of parallelograms, and we're going to do the proofs that pertain to them. So this first proof, we are given that AB is parallel to CD and AD is parallel to BC, and that we have a parallelogram ABCD. So we're going to prove that sides AB and CD, which are opposite sides, and AD and CB are congruent. So what we're going to do is prove that these opposite sides here and those opposite sides there are congruent. So first, you guys have on here that ABCD is given, that we have a parallelogram. Then we're going to draw a segment from A to C. We're drawing this dashed line right here. And then we're going to put this given piece of information up here, that AB is parallel to CD and AD is parallel to BC. Then let's look at these angles here. 1 is congruent to 2 and 3 is congruent to 4. So let's go ahead and mark this in the drawing. 1 is congruent to 2, and 3 and 4 are congruent. So you should be able to see that those are alternate interior angles. So that's why we can make that statement. Oh, by the way, we could also have put in down there in the bottom that last step, because that's what we're trying to prove. So remember, I said you can always fill in the givens first and then your last step. So let's go ahead and put that there, alternate interior angles. Then we have the reflexive property. Now, if it says a reflexive property, we're looking for a shared side. And that's what this is right here. That's our shared side. So that would be our reflexive property of congruence, and that is AC is congruent to AC. Then we have triangle ABC is congruent to triangle CDA. So hopefully all of y'all can see up here. If we're looking at these two triangles here, we're looking at this triangle right here. And if we look at this triangle and we move around it, we should be able to see that we have got angle, side, angle. That's why those two triangles are congruent. So that's what we're going to write here. And again, we've already filled in our last step, number 7, which basically tells us that if the two triangles are congruent, then all their corresponding parts are congruent. For the second one, we're going to prove that opposite angles are congruent on this one. And again, we have parallelogram. We have this quadrilateral ABCD, and we have the opposite sides are parallel. We're going to draw the segment from A to C. So this piece of information here, AB is parallel to CD and AD is parallel to BC, is given. That piece of information was right up here under our given statements, as was the fact that this is a quadrilateral. Then we're looking for some alternate interior angles again. It says over here on the right for our reason. So here we're going to say 1 is congruent to 4 and 2 is congruent to 3. Those are our alternate interior angles in this problem. And then step 5 says AC is congruent to AC. Again, this is going to be our reflexive property of congruence. That's our shared side. And notice it says angle, side, angle on the right. Well, that means that we're going to be talking about two triangles being congruent. So notice up here we have triangle ABC, and that would be congruent with CDA. And remember that we went from 2 arcs here to nothing to 1 arc. So that's what we'll do up here. 2 arcs to nothing to 1 arc. So that would mean that we would say ABC is congruent to CDA. Then it says here the measure of angle 1 is equal to the measure of angle 4, and the measure of angle 2 is equal to the measure of angle 3. Now we have that piece of information up here in step 4. So remember, when we go from congruence to equal or equal to congruence, we're always going to put the definition of congruent angles there for that reason. Then we're going to talk about the substitution property of equality, it says here. So we're going to substitute in values. So I want to show you what this looks like here. So on this one, we're going to say that the measure of angle 1 plus the measure of angle 2, that would be all of this right here. And the measure of angle 3 plus the measure of angle 4 are going to be equal to each other. And we know that because 1 and 4 are congruent and 2 and 3 are congruent. Then let's look at step 9. So I would like you guys to look at step 9 and look at your drawing. Again, look at step 9, look at your drawing. You should be able to see the segment addition postulate here. Or not segment, sorry, angle addition postulate. So we're adding two angles together. Notice we're adding angle 1 and 2 together, 1 and 2 right here, and they equal A. Adding 3 and 4, and they equal C, the whole thing. So when I add these two angles together, 1 and 2 right there, I get all of angle A. When I add angles 3 and 4 up here, I get all of angle C. That's what we did. Then it says the transitive property. If you guys recall with the transitive property, if we have 3 or more things, we can then combine them. Up here in the step before, step 8, it told us that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 and 4. So that means these two parts right here are equal, which ultimately means we can put those two parts right there together. So that's going to be our next step, is putting those two parts together. So we're going to say that the measure of angle A is equal to the measure of angle C. Once again, we're going from our equal sign to our congruent symbol. And on this one, we're going to say it's the definition of the congruent angles again. And that's what we were trying to prove, that A was congruent to C and B was congruent to D. So that's exactly what we would be doing here. Okay, so the next one. Again, this time we're going to prove that diagonals bisect each other. So on this one, we have our given pieces of information that we have quadrilateral ABCD. We're going to, again, draw that segment from A to C and from B to D. And then we're going to put our additional given piece of information. Now look here at step 4. It's talking about ABE. ABE is this angle being congruent with CDE. So again, those look like alternate interior angles to me. And we have DCE. DCE. Wait. DCE, yes, this one right here is congruent with BAE. BAE is this one up here. Now, if we're making that statement, then we're talking about the given information of things being parallel, because those are alternate interior angles. And if we have that first for step 3, I did step 4 on my drawing first so it could take me back to step 3, because that's what would have had to have been there for me to make those statements. So then our other piece of given information would be down here for step 5, because that's the only thing that's left. We already talked about step 4. Those are alternate interior angles. And then look up here at the drawing. And we have AB is congruent to CD. AB is congruent to CD, right? And then we also have these other pair of opposite sides that were congruent. Now I want you to look at that top triangle, ABE. ABE. I'm going to go ahead and do it in green so y'all can see it. ABE right here, this triangle right here. Hopefully you can see why that triangle is congruent with the one below it. It's angle, side, angle. So that's what we're going to write here for step 6. And again, step 7 is filled in already because it's what we're trying to prove, that the diagonals are bisecting each other. And we can do that again because if those two triangles are congruent, then all their corresponding parts are congruent.